Yeah, g'day and welcome back to my lathe channel. This week I'm powering up my controller. Haven't finished wiring it yet, but I've got the first systems working, so let's take a look at that. Cool, mail time. Man, now that is some ridiculous packaging, huh? Ah, good. I'd run out of wire. This should be enough to get finished. Last week I hooked up my 3 phases, each of them having these jumpers, and I think I triggered pretty much every electrician who watched that video, because this is not safe, this little gap here. So thanks very much for pointing out this issue. Let me just get in here. Shove those across. Now, while I did of course consider just cutting these out of ice cream container, I did buy the proper ones from Phoenix. Oh what? Hadn't done that up yet. So that looks a bit better. Thanks a lot for looking out for my safety. I really do appreciate that feedback. Do you remember what you were doing when you heard that Lady Diana had died? I do, because I was on a night shift. I was replacing the hydraulic pump of a Canadair regional jet, and I remember hydraulic fluid was running down my arms, so I wandered back to the bus to grab a rag or something just to wipe it all off, and that's when I heard on the radio that she'd been in a car accident. So it's funny how these things become so indelibly etched into your mind. Mail time again. For motor overcurrent protection, I was going to just reuse these old current protection circuit breakers, but modern ones are more narrow, and by switching to the narrow ones, and by shoving these things over a little bit, I made enough space here for one more contactor. Main contactor for the spindle, main contactor for the coolant pump, a contactor for the axis drive system, and still have 2 left over, which I can use to replace this old variator control board from Schaublin. Now this is drawn on the actual schematic, and I sent it to my electrician friend to discuss the hookup, and he pointed out that it's missing any form of protection if you screw up the control wiring to it. For example, if I by mistake have LinuxCNC try to power both directions at the same time, it'll probably blow it out. The probability of me screwing something like that up is pretty high. So Stefan whipped up a drawing for me showing how I could replace that control's functionality with 2 contactors and their auxiliary contact blocks. I can basically do all of the functionality of that module, but with additional safety. Now I just need to wait for that last contactor which I ordered to arrive. I'll leave that DIN rail on there. Might be useful for mounting some terminal or something. For the spindle, I've got all the power wiring done. Now I just need to bring it under control. And I think the easiest way to wire this is going to be to use a Cat5 cable, butcher it, because I've got a 0 to 10 volt analog signal, and it suggests to use a twisted pair for that. Because I've got 8 wires to connect up, I can use the contents of a Cat5. So I need to connect this to this, but I don't really want this wire just hanging out in space like this, so I think I'll make up some sort of a bracket, and I guess the easiest place to attach it's going to be here. Make up some support bracket and then a P-clamp to hold this. Glad I wasn't holding that with my finger. Let's try that again. Now I'm not sure if I actually need it here, but I'll do it anyway. I'll try folding this shielding sheath back on itself. Probably going to make a bit of a mess there. Clamp it with my P-clamp. Well, it looks a bit messy the way I've terminated those thin wires down here, but now I can continue on and connect them up to their services. Need a twisted pair for the analog wiring. Have to over twist it a little because it kind of untwists a bit, but that method does make a pretty nice job of it. I've got my three-phase power connected up. Line 1 and line 2 power the X and the Y axis controllers' brains, only the logic circuits, so they should power up as soon as I switch on. I've got the two DC power supplies, 5 volt and 24 volt, which are also powered directly. So that means that the power should come onto the safety relay and onto the Mesa cards. I've got the e-stop off, so no power should get to the VFD. Let's try that. Okay, they came on, that's good. No power. No power. So what's happening with my DC? Yeah, this is the input side. I haven't made a circuit. So far I've only connected the two neutrals. I still need to connect line 3 to the other side of the primaries. Okay, power is off. Right, now that those are wired up, let's try this again. Okay, that looks more like it. So we now have our 24 volt power. We've got our safety relay on. Obviously we've got no communication on the Mesa cards, but they have received power. If I release e-stop, nothing happens. Right, because I need to both release e-stop and also send it an enable command, and the enable command comes from here. So the next thing I need to do is set up the computer, connect up the Mesa card and start commanding it. Boot this up. Okay, I've got some behavior I'm not understanding. When I turn it on, I get power. The 5 volt power is powering up this board, and it stays powered up for maybe a minute or so and then goes out. It says network is unreachable. Well, after a bit of troubleshooting, it looks like my 5 volt power supply is not working reliably. It says 5.1 volts of output. The problem I was having on that power supply is that I was getting fault lights here and I couldn't ping this board. With it connected to my old butchered ATX power supply, the board works fine, pings fine, connects fine. I think there's definitely something wrong with that little power supply, because now I set it at 4.8 volts without any load, but it drops to only 3 volts with the Mesa card connected, and the Mesa card is showing fault lights. Right, well I think that's enough mucking around with the faulty power supply. I'll just use my little ATX power supply to power the 5 volts for now. Right, looking in here, this is looking good. I've got my main Mesa brain and it's 2 connected daughter cards at the moment. The 7i83. This is the one that I'm going to be using to control my VFD. And there's an enable signal which is currently false, and there's an output signal which is currently 0 volts. We're testing that soon. And then my I/O card, output 0, should have set this active. So I need to have a look at why that's not working. You can see the safety relay comes out of e-stop, and because of that, power goes through the time delayed contacts here to power this relay to close, which gives power to the VFD. And if I kill it, it sends a shutdown command to the VFD first, instantly, but then takes 2 seconds to disconnect the power. Right, so now I've got this powered up, I can go through and set all the parameters. For that I've gone through the manual, looked up all the most important parameters. The one thing I can't find is the data plate of the engine doesn't list the cosinus phi value. I'll just leave that at its default value for now, and if anyone's got any ideas of what cosinus phi I should set on a motor like this, I'm all ears. I worked out the slip. It's a 1440 rated speed motor at 50 Hertz, which means it's got 4% slip, 6.7 amps, 2.94 kilowatts according to the data sheet. So I'm really just missing that cosinus phi value. To start with, I've been pretty conservative. I'm only going to set it for a minimum frequency of 20, and the maximum speed I've set is just 70 Hertz. I'll muck around with this later, but this gets me started. And my acceleration times I've set for 3 seconds accelerate, 2 seconds deceleration. This machine's got a mechanical brake, so the acceleration's not going to be a big problem for it. This should only run when it's out of e-stop and when the enable pin is activated, but it's going on automatically. So I've got something wrong with that activation circuit. I need to fix that. Let's hook it up and get that motor turning. I'm recycling the cable that was already in the machine. It's a nice oil flex cable, shielded. The shielding's been terminated. Of course, because it's a Darlander motor, it had 6 cables to it. 3 are disconnected and safetied in the terminal block at the machine. When I short 4, 5 and 6, I get 10 ohms between the phases here. And if I short these 3, I get 5 ohms between the phases. So it looks like this is my high speed 4-pole winding, and this is the low speed 8-pole winding. Right, here we go. With this hooked up, let's see if we can get this beast to do something. Alright. Right, let's try a speed change. Okay, so it's not following a speed change command, so it must be some setting in the VFD I need to change. Okay, so I want to set the speed via pin 8. So it looks like I need either 0 or 2. Parameter 1. We're in mode 0. That seems like the way it should be. Oh, wait a minute, I just realized. For the analog output voltage to be set, that same analog output has to be enabled. So I needed to set the enable to true. So now it will follow the voltage I set with analog output 0. Let's try that. Maybe we can also get it to change direction. Okay, speed reversal works. Well, there we go. The gearbox is not actually engaged, it's just being dragged along by friction. As always, it took me much longer to get this up and running than I was hoping, so I'll stop now and try and get a video edited and uploaded by tomorrow. I actually put a lot of work in this week on wiring. I didn't video most of it because videoing wiring gets boring, and I've done enough videos on that already. But I'm in awe of guys like Clo42 who can do one video and do a whole completed control cabinet in one go. It's been taking me a lot longer than that, but I'll get there. I still need to work on the whole drive enable thing. It's not working the way it's supposed to, but otherwise, pretty happy with the progress. See you again next week. Thanks for watching.